Hello, it's Duncan. We're going to take a little detour in our bowling game project to address feedback from friend of the channel, Tim. Firstly, we'll see if we can improve the readability of our tests. Tests often reflect the combined complexity of the code they're testing. If the tests themselves are too complex, then bugs can hide there, so we should strive to make them as expressive as possible. Secondly, we'll look at forbidding knocking down, say, 11 pins in a frame. I don't think we can do that in Kotlin using just the type system, so we're going to have to resort to runtime checks, but even they turn out to be convoluted. In the end, I stumbled upon a solution that mixes extension functions with methods to bend the types without too much complexity, but let me know in the comments if you have a nicer solution. There was some discussion in the comments of the last video about using the scorecard here, this sort of thing, as our primary tests. The problem at testing at such a high level is that if we make a change, for example adding scoring, then we have to change all of the scorecards. Now we could write tests of just the scoring, but personally I like this approach, effectively of testing through the user interface, because it means the tests are quite dense, they communicate a lot, and they're easy to read. At the moment they're still quite noisy. We've got all this game to scorecard is equal to, we've got the triple quotes and so on. And in fact worse, I think if we were to reformat this, yes, there, and if we remove the custom line breaks, you see that IntelliJ's default formatting is really quite sparse, and I think makes everything a bit less readable. Maybe we could address that by not using the triple quoted string. Let's see how. First of all, we can push some of the noise into another function. So if we take this string here, for example, and make a variable out of it, don't care what it's called, then if we extract this into a method, then IntelliJ will have to replace all the other calls that look like this one. So that would be really useful. We'd say yes and all. So everything's a bit less noisy. We'll run the test to check that that's okay. And it is. And now we can inline the string that we took out, which I've lost a bit. But there it is. So let's inline that. Okay, that's a bit better, but we've now got this odd game comma such and such. We can fix that, I think, by going to extracted, naming this as expect scoreboard, and now making game into the receiver. So that now pulls game outside and makes this a more consistent formatting. That's good. Can we do better? Well, these sort of scoreboard are in fact only one line. So we'll go to the first one of these, looks like that. Let's go up here, where is it? I guess here. If I select that and do the multi-select thing, like that, until we reach the end. Now I can use the multi-select cursor to go to here, delete, take out that, like that, and now also we can put the character turn in at the end by hand. So I can go in here and say delete these and do that. And now if I go to the beginning, I think I might be able to say that all of these want to be an ordinary string literal. There we go. Oh, and just one irritating place there, it's got one \n. Well, it only actually appears to have fixed up this one. So let's do all these others. Let's go to the top, take this, select all those again, that, go to the beginning, delete those two, go to the end, delete those, run that. Okay. So that's neatened up all of our games with only one player. Let's go and have a look at the game with more than one. We'll just fold this away and that for now. And here we have our game with Fred and Barney. Can we do the same sort of thing there? What I think I'm going to do is add another version of expect scoreboard. So we take this one out of our test just to show that it doesn't depend on anything inside it. That's true. And then we can say, what if we had a version of this that took varargs? So this would be lines, which is vararg. So if I passed in a list of lines effectively, then what we expect is that our scorecard is this lines joined to string with \n. Now we're not calling that one yet, so let's go up and work out how we can. What we want to do is replace this with a literal string and a comma. So I think, let's get it's all looking exactly the same. For some reason this one is indented slightly differently. There we go. Okay, that stands a chance. We'll go back up here and we'll say let's take this thing, select all the occurrences of that, and now let's go and edit. So we'll go to up, convert this into a string and bring that like that. End of the line, put in the quote, put in the comma, go to the beginning of this line, put in the quote, end of the line, and now we'll delete all those quotes. Reformat. And now, messed up the first one, so we'll fix it up by hand. So this is expect scoreboard like that. Run that. That's good. And this is now calling the varargs version. Now that we've done that, we have a quote character here as the end of our line, so we don't need this dot to show us the white space. To get to remove that though, I think I'm going to take these ones here, the render strikes and so on. If I take out these, is that all? Not that one. I'm going to take out the \n from the top. And now if I delete this expect scoreboard, then these ones will all be called the vararg version, and I think should still pass. So let's try. But it looks like we just have a problem with the very top one. Let's have a look. Oh, I didn't fix that up. So this is now that Fred, Barney is an empty game. Good. Now we can say we don't want the dot by selecting all of them. That's everyone in the file. And just deleting the dot. That should fail the test. And does until I go into toScorecard, which is here, and take off this dot. Good. And now, in fact, I think we can see that maybe a scoreboard should actually be a list of lines rather than a single string. In which case, if we go off here and say that game to scorecard is list of string, then we don't join to strings, we just map. So this is lines, map, line, scorecard. I think that probably won't compile. Let's find out. Yes, because here we're matching an empty string. This should then be an empty list if we have no players at all. And then here, we won't need to join these to string. It will just be the lines to list. Good. And if we're right now and we reformat this file, even with custom line breaks gone, then IntelliJ's default formatting is now something that's really nice and readable for us. With the possible exception of here, I suppose, where it's been a little overzealous. So maybe we'll just undo, because it turns out we do want these custom line breaks here. Okay, I think that's a good place to check in with nicer test formatting. And I want to address something that Tim brought up, which I hadn't noticed as I was writing this code, which is that we actually have an illegal state here. We've rolled a 5 and then we rolled a 6. But there are only 10 pins, so we couldn't possibly roll a 6 the second time round. Now our game should stop us from doing that. The question is how? Before we write the functionality, let's just write ourselves a little test. So this is can't roll invalid pins, pin counts. Now it's already the case that we can't create an invalid pin count. So if I try and say pin count 11 and run this test, you see we get an illegal argument exception, failed requirement. Have a look where that is, and that is here, and it's because we require the pin count to be between 0 and 10. We can make things just slightly better by adding a message, which would be invalid pin count value. Have a look. And there we get invalid pin count 11. Let's lock that behavior in with a test, so we can say expect throws illegal argument exception when we do that. And by the same token, we expect -1 to fail as well. Good. I think maybe we'll call this can't create invalid pin counts for the actual object, and then create another test to show that we can't combine them invalidly. So this is can't roll invalid pin counts, And in order to show that, we'll start with a game like this one. And then we'll say game is game roll pin count of, say, 9. That's playable game. And now we want to say what happens if we rolled 2. And what we want to happen is this illegal arc intersection. Run all the tests. The failure we're actually seeing is a class cast exception because that was the last roll. But if I take that out, we should see what we expect, which is that this returned a completed game rather than throwing an illegal argument exception. So now let's look at different ways in which we could make that happen. Here on the right hand side is our frame, and you can see that every frame has a total pin count. And the sort of thing we want to be able to do is check every frame doesn't have an invalid pin count. Now the first thing that comes to mind for me is to add an init method into here. So we can say when you create one of these things, require that the total pin count value is less than or equal to 10, say. Now that won't be true for the final frame where we can roll 3 balls, but it would be a start. But it's scuppered because we can't have an init method on an interface. Well, okay, I suppose frame need not be a sealed interface, it could be a sealed class. If it was, then total pin count would have to be abstract. But now we can require whatever we want in here. But first, in fact, playable frame as an interface can't inherit from frame as a class. So I suppose we can make this a class as well, and then it would call the constructor there. And then roll, what's the issue with that? Again, that would have to be abstract. Okay. Likewise, a completed frame will have to be a class. Call the constructor. And now, though, we can just go through and call the constructors in these places. Okay, that was the last error. Let's try that. But that hasn't worked. That's a bit strange. I'll go and do a bit of battle with the debugger. Okay, here we are on the debugger. We stopped here when we're doing the second roll. And inside that, we're stopped here. So this total pin count value is less than 10. And you can see here we're initializing the normal completed frame. So let's ask what this evaluates to. And the answer is 0. And the reason for that is that we are in the constructor of frame. It's trying to create a normal completed frame. Where's one of those? There it is. But the init method for the base class is being run before the constructor of the subclass. So our roll 1 and roll 2 properties haven't been initialized yet, and they get the default value, which is 0. This sort of thing doesn't seem to happen as much in Kotlin as it used to in Java, which is probably why it's bitten me here. Okay, let's kill that debug session and think again. Going back to our frame, we need some way of getting what the total pin count is to be right in the base class. Well, actually, there is a way we can do that, and that is to say we can make it not an abstract value here, but a constructor parameter. So we can say we'll move this into there. Now, playable frame and completed frame don't know what to do, but we can say add the parameter to constructor. So we'll just get that out a bit more like that. Same here. And now for our concrete subclasses, like unplayed frame, we can pass what we'd evaluate to total pin count up. So here we can say an unplayed frame, its total pin count is score 0. So instead of having a getter for it here, we can pass it to a superclass. Like that. Same thing here. Our total pin count is the score of roll 1 value, but that is available from here. So we can take this out of there and put it into there. Okay. Strike, well, that's always 10. Normal completed frame, that's the score of roll 1 plus roll 2. And let's try that. Oh, good. Let's check all the tests. And in fact, we have the place in play a game here where we shouldn't have been able to roll a 5 and a 6. So let's change that to a 5 and a 4, and then go back to 3 and 2. Good. So that gets us passing now, but there is a fly in the ointment, and that's what happens when we reach the final frame. I'm going to sketch that in. At the moment we've got an unplayed frame here, but we're also about to have an unplayed final frame. Now I don't know for certain because I haven't played this through yet, but I suspect we're going to need unplayed versions of all of our current states. If only because the strike at the moment is a completed frame, but a strike in the final frame won't complete. So I predict we're going to end up with a last completed frame, which has potentially 3 rolls, and where the total score may be more than the 10 that we've hard-coded into the base class. I suppose we could solve that problem by passing up not only the total pin count, but the restriction on the total pin count effectively is 10. Default parameters might make that work, but it really is going to complicate the model a lot. So probably let's not do that, just undo these and try and think of something else. Check that we're back in business, and we are. Now one thing we could do is to say that the total pin count is in fact a pin count. If we did that, then the init in pin count would make sure that it was in the right range, that it couldn't be more than 10. That would be solving the problem with types. The only problem is that our as yet unwritten final frames, their type can't be this pin count, it would have to be something else. Let's try following that through. We'll undo this so that we compile. And now let's add a type for the total pin count for the final frames. So we'll go down here and we'll say we've got this class here. We'll just duplicate this, I think, and we'll say this is our final frame pin count. And that can be between 1 and 30 if we score 3 strikes. Armed with that, we can make our frame, this type here, into either a pin count or a final frame pin count. So we might be able to say extract a type parameter, and in this case it's saying yes, that could be t, which is some sort of score, but we don't actually want to be score, we want to be a common supertype between our pin count and our final frame pin count. So let's go down there and we'll say that here's our pin count, here's our final frame pin count. Let's introduce a type here. It can just be an interface, which is, we'll call it number of pins. And I think probably number of pins wants to be able to tell you its value. So we say val value, which is an int. Now, if we make this into a number of pins, then this needs to be an override. And we can make our final frame pin count the same. So we'll just lay that out first. Say this is a number of pins, and that needs to be override. Okay, back to frame. And this wants to now be number of pins. Playable frame and completed frame, well, they're sort of markers to say whether we can roll or not. I think they are going to have to be generic in number of pins too. So we'll say this is playable frame, number of pins is a frame of t, the total pin count is going to be our t. And now what is the type of the frame that this returns? Well, I think it's going to be consistent because it's only our final frame that needs a different type here. So I think this can be a frame of t. Chase that down, completed frame. This is going to be t. This is going to be t. This needs a t. Okay, normal unplayed frame then is a playable frame with a pin count, not a score. And we need to tell it that this is pin count. Okay, what's our issue here? Return type is any. I think that's only because in progress frame and strike aren't compiling yet. So we'll go down here, we'll say an in progress frame is a playable frame of pin count. And now instead of rolling up to a score, we can say this is just roll 1. We're going to have to get everything compiling, I think. So a strike is a completed frame of pin count, where this is a pin count 10. Normal completed frame is a completed frame where the type is pin count. And this roll 1 plus roll 2, well, that's where we're able to lean on pin count to do the checking for us. So that's roll1 value plus roll2.value. Does that compile? Oh, we're getting there. Some issue here with unplayed frame. Quite what that is, let's have a look. This says we require a frame of score but found unplayed frame. Why is that? I suppose that line, yes, there we are, we have frame of score. So a line, we don't care the type of the frame, so I think we just use star in there. Okay then, that compiles. Drum roll please. And it passes the test. Well, I think there's also one thing we can do now, which is that we can take the require out of here. Because in order to build a frame, we have to be able to construct the proper type of number of pins. So I think that can go. And it turns out I'm right. Our check for the invalid roll is coming in the place where in our normal completed frame here we're building a pin count. So that here. And if our two rolls added up to too much, then pin count would fail here. Well, it's painful and it passes a test, so that feels like a good place to check in with checking for invalid pin counts. Okay, so it looks like we can solve our problem that way. The question is, should we? Looking at our tests, this horribleness of frame star and so on, that hasn't actually leaked into our interface, which is a good thing. But goodness me, all these playable frame stars and this is a T of number of pins and so on. It is all really quite horrible. I'm not sure it can live. So what I'm going to do is I'm going to go back and let's revert the change to our implementation and try again. Now our test should fail and do where we expect, that's good. Now this time round, I did like having the total enforced by the type, either pin count or final frame pin count, but that caused us lots of problems with the type of frame. What we could do instead though is take total pin count out of frame altogether. I'm going to remove it from here and see what that breaks. So first of all, well, unplayed frame has a total pin count, but it has nothing to override. Well, not a problem, let's just let that work. And we'll do the same in the other places. Okay, now if we try and compile that, then the place that we were using it, which is here, frame total pin count, can't work. Now I wonder whether it could in principle, because after all the compiler does know all the subtypes of frame and knows that they do all actually have total pin count defined on them. It's evidently not that clever, but we could help it along by adding an extension function, or in fact an extension property, so let's do that here. So we put that on frame, and given that we're just going to do maths with it, I think we may just make this an int. Now let's see what that affix is. Well, that's fine, except here where we need to be able to add an int now to a score. And the same is going to be true here. So let's go to our score and say, if we had a plus that took an int, then we could make that work like that. Okay, we know we've got a to do, so let's go back to that. It's down here. And now frame total pin count we can implement with get is when this, and then ask IntelliJ to fill in for us. And now each one of these types has a total pin count. So this is this dot total pin count value, and each one of these is the same. And in fact we can lift this, not automatically it seems, but by hand out there. So like that. Now, I don't think this will pass the tests. Can you think why? Well, I'm right that it failed. Let's see where. I guess, well, where we might have expected. And I think the issue is that this frame total pin count here is only used when we render a scorecard, but here we haven't tried to render a scorecard. I think we're going to find our problem earlier than that, going back here, and say that each of our frames will eagerly evaluate total pin count as a field rather than a getter. So if we do that, and that, and that, and that, and run. Oh, I'm an idiot because I've left these all as scores. So in fact, this should be not score, but pin count, roll1.value, roll2.value. We need to fix the types in all of our normal frames. So in fact, in strike, it is just roll1. How's that? Brilliant. I think on the whole that this solution to the problem isn't as safe as the version that had a class here with an init method in it, because it does rely on us eagerly evaluating a pin count in order to populate a field. In return for that, though, our types are a lot simpler. I find that's a common trade-off in Kotlin, that as soon as we try and solve a problem with generic types, everything gets a lot more complicated, a lot more noisy. In this case, we've used this frame total pin count and the fact that we have sealed types to sidestep the generic type with basically a bunch of instance of checks. Looking at our frame types now, we'd have ended up with an interesting mix. We have subtypes over on the left-hand side here, and a polymorphic method roll that's implemented different ways by different types. And that's representing our state machine. On the right-hand side, we've got these two properties, total pin count and roll1, where the type hierarchy really wasn't working for us, or at least we predict it won't when total pin count can have different types. This roll1 here, I still don't know about. I suspect that we may well end up having roll1, roll2 and roll3 rolled up, if you'll pardon the pun, into frame in order to complete our scoring, but I might be wrong. If you'd like to find out, then please subscribe to the channel, like this video so that YouTube keeps on showing them to you, and maybe even buy the book that I wrote with that price called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.